Hello. Whew. I'm exhausted. I was working all weekend on the bhop AI. I should probably name this stream title better. Let me call it training classifier. There we go. Yeah. Okay. Whew. So what am I gonna do today? I have an AI that's ready to be trained, and I need to like make the data good so it trains good. Um, I have acquired. Oh yeah, I have acquired a big old data set, which is my data, my game. It's 21,000 replays of players playing my game. Data. And it's associate. All of the replays are associated to a specific player. And the idea here is the classification is either cheating, not cheating. And we have this large database of moderation history where the moderators have said this player is cheating, this player is not cheating. So what I can do is with my data set, organize it such that if any single one of a player's list of times is cheated, that means the player is cheating. So this training regime, it's actually a little bit complicated. Oh my god, bruh. Training. It's in here. So I have a convolutional neural network. The replay is over time, right? You're like doing this or something in the game, and you're pressing keys. So that's the number of inputs. You have 7 inputs: WSD, jump. So those are either 1 or 0, and then your mouse position or mouse delta, X and Y, and that's how you play the game. Those are the inputs. So by inspecting the inputs, it should be able to tell whether or not you're cheating, because that's the only way to cheat, is to create inputs that a human could never make. So really it's just detecting whether you're a human or not, or if you're like just time scaling or something. There's a lot of ways to cheat. So this is the network activation. It does a convolution, and then the neuron activation, and then it pools them together. So let's say that your replay has 1,000 frames, where it's like I press A, I press W, I press A, I press W. The pool, the convolution goes and like produces a new list of neuron activations. So this is like your list of inputs, where it's like WSD, WSD, WSD. Now it goes from that to 7 to 32. So it's like a list of 32 neuron activations at a time, the same length as the replay. But then the pool takes 2 at a time and pools them together, takes the maximum value. It's a max pool in one dimension. So the replay, if it was 1,000 frames, now it's 500 frames by 32. And then we do it again, but this time we just stay 32 to 32. And then it becomes 250 frames. And then do it again, but make it bigger, because we're gaining more information here. I think I might actually just change it to be flat, because I don't think it needs to get bigger. And it just like makes the neural network bigger for no reason. It's just more expensive to run for no reason. I think that it can classify this stuff with like 32 or 64 neurons per layer. So yeah, it repeats this 7 times. So it's 128 times smaller after all of the pooling. And what that does is it lets each layer look at a higher level. So it's like you're zooming out. So imagine it's a picture and it gets half as big each time. And like the convolution only sees a very small portion of the picture. But if the picture is getting half as big, well, now the convolution sees a bigger portion of the picture. So it's looking for features, like facial features sort of thing, in a two-dimensional convolutional neural network. But this is a one-dimensional convolutional neural network. So I'm looking for like strafing features. And I mean, it seems to work. So that's why it's called features here. Oh dear. Oh, that's very chocolatey. I made it huge. I mean, it's kind of big. It's like 90,000 parameters. Previously, it was 6,000 parameters. I feel like I can just bring it down. Right. I want to like do A/B. I want to do experimentation on like the sizes here and like see what's good. I expect that because I have so much data, that larger will just be better. It'll just be outright better. More parameters is more better with more data. And that's about it. It can just learn more stuff. But like I kind of want to keep it small so that it's not like learning edge cases where like it learns that this one player should be classified wrong because they're actually cheating even though we said they're not cheating. And like with more parameters, it can like do most of the network towards like normal classifications and then identify the one player that we misclassified. And that's like, yeah, but I don't know if 128 is big enough to do that. It's still kind of small. I don't know. It's a kernel. I think it's no. That's not the kernel. The kernel's 3. Yeah, no. This is layers. I have no idea. I've seen a convolutional neural network that classifies images, cat, dog, that looks a lot like this. This is convolution in 1 dimension, 1D, conv 1D, but that was using convolution in 2 dimensions, conv 2D, and pooling. I really like the pooling idea, so I lifted it. I don't know. I just thought that more layers would be more better, because I want to see big strafe features. How the cheaters act playing the game. Okay, what I was trying to talk about was actually this training on a data set. So this is like a list of users' replays. So each item in this slice is a different user, and each tensor in this vector is a different replay. So for each user, for each time, for each replay, do the neural network, and then find the maximum cheating value of all of that user's replays. So it does the convolution on all the replays. So let's say there's like 7. And then it does the maximum cheating value of all 7 to just output one single value. Are you cheating? Are you not cheating? 1, 0. So yeah. This does the maximum over the entire replay. This does the maximum over all the list of the user's replays. And now you have a singular neuron, a singular floating point value, and then you just make a list of all of the users. So it says This user, yes, cheating. This user, no cheating. It's just ones and zeros. Is this user cheating or not? And then that is the information we have. Is blacklisted or whitelisted the moderation state. So it can learn what a blacklisted user's replays looks like and a whitelisted user's replays looks like. And then it can predict a new user or a specific time. Because, like, not if a player is hidden from the leaderboards for cheating, which is what blacklisted is, not all of their times are cheated necessarily. Maybe they are. So that's why this max is useful, because only one of them has to trigger the like cheating threshold. I think it makes sense. I think this is like really well engineered, but it's a little bit suboptimal for like speed, because it's forming a really complex matrix multiplication graph, and like, but it describes the utility function well. It can gradient descent good. I think it's a very accurate training setup. Okay. Do I want to make it small? Or do I want to leave it with the giant hulking neurons? Yes. The 32, I can't decide. Really, what I need is to train it and then, oh my god, bro. And then see. Wow, I love ads. Ban. I'm just going to go 32 here. And because I want it to be fast to train. Oh. Fixed user replays max. Oh my. Oh. Pull out parts of model elevation. Oh, okay. Smaller network. Okay. So that's what I wanted to do. So now in the angles thing here, I don't want to do this. I want to steal this. Right here. Oops. Lib source state. Okay, so this stuff is the sensitivity state. Oh my goodness. So I'm gonna go like struct settings state zoink, and then put this excuse me, like this. And then this one setting, yes. Very good. It changes the settings, and then er, e, er, uh, get sensitivity. Yeah, yeah, and then is that? No, 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 no. That's just wait. It's const. That's cool. DVEC. Nah, 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 no, 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 no. We don't do that here. Okay, so we got them. This is just two floaters. F32, F32. Oh, crap. Is this a f? Input event. Is that a float 32? How and what? Oh, it's a vector 2. Okay, that's why. Okay, I see. This should be okay. Should be okay. Indeed, indeed. We can say F64, F64. That's okay. 364. That's a big float. Okay, so FOVY. There it is. Dun, 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 dun. Game controls. Oh, hell nah. Oh, hell nah. Oh, hell nah. Oh. Ah. Process event. Yeah. Event type, event index. Like we only need input and setting events. That's all we need. This is a bad architecture, but it's okay. It's okay. Did I remove the dependency? Oh, I don't. It does not there. Okay, good. I don't like it. Okay. Yay. You know, actually, game controls could be supplied externally. Because I have the input for all frames. I'm not exactly sure exactly how the sensitivity is accumulated. The mouse position is accumulated. All right, let's go for external here. Game controls. Oh wait, come back, dude. Let me code. Okay, there you go. Game controls contains, and then again. That's right. There you go, bud. Okay, so now it's external. Yeah. Okay, that solves it really. Um. Oh. Oh. Do I use iter tools? Because I really have to merge sort these two lists. That would be easy, wouldn't it? Mm. Game is easy. What? Next, unwrap. Does that work? I don't know. Merge sort. Hmm. No, I guess it would be from there, eh? Hmm. And then I have a little match. Functions. Mm. Yeah. Okay, that's fairly isolated. So let's give it a shot. Okay, so function. Push, push, push. Input. Mut inputs. Vec frickin' what? F32 inputs. And then the input event is a input event. No way, bruh. Do we care about the time? We literally do not care about the time. Okay, brother. And it's a goddamn reference. Okay. And that is basically where this code goes. Gabagoo. Except I also need the state. Settings, state. Settings, state. Okay, bud. And then sensitivity. We'll just say sends X sends Y is equal to input event dot that one. Yeah. Okay, and then this can be smaller now because this goes away, and then we say maybe I put this up here, and then I say with brackets. Should I call this like motion or something? The motion. We got the motion. Boom. Oh. As F32. Yeah. Oh, that got smaller. I like that. So is wait mouse. Turn. I like this music. Human music. Maybe I should do I8 here. I just realized it's probably simpler because there's no like overflows. Capture. Ah. Indeed, sir. Very true, sir. Sir, so true. So true. Uh, very true. Sir, that is so true. Okay, so we can actually say pause outright here. Like, it's kind of dumb that it's two values. Last mouse pause. And then say last mouse pause is a mutt friggin' butt vector 2 slant. And then we can say star. Got him, coach. Okay, and then strafe. AI mod man. Cargo add iter tools. Freaking iter tools. Default features. Let me try that and see what we get. All right. Da 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 da. Okay, so we've got freaking iter by type situation. Iter tools. Merge. Join. Merge. What is K? Into iterator enabled version. What is K? What is merge join? Is that the one? Is it the one? Is it real? It better be the one. Iter tools. Show me the money. Merge join by. Okay. Okay. Right. Right. So we want to run settings first. So is it timelines dot settings dot iter? Oh, iter? I don't know. And then it. And then the function is setting freaking input setting dot time less than equal to input dot time situation, and then match. This is just like event. It's one or the other. Either indeed, and then blam blam. Iter tools either. That's the either crate, right? Yeah. Okay. So this is freaking input event, setting event. Okay, bud. Setting event, input event. Push input. Ha 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 ha. And then this is input event dot event. This is setting. No, yeah, setting event dot event. Do we need the? No, we don't need the time. Okay. Then this is like push setting. Dun-dun-dun, Yeah, okay. Push setting. Not real. We need to make that a reality. Indeed, indeed. Yes, sir. Yes, sir. Yes, sir. May I take your hat, sir? Push setting. Mutt. Ah, and then no. Setting event. Ah, setting. Uh. Ah. Ah. Okay, and then. Ah. Mutt. Who? Last. Yeah, man. Okay. Let mutt settings state equals settings state new. And then we do setting state up. I think that might be it. And we can just forego this entirely. Close dot event. Okay. It's all coming together. Freaking the itter. Okay, we don't have ownership. I don't think so. Yeah, so we don't want to be doing stealing the ownership. Okay, great. I think this is done. 128. Oh, goddamn. I think this is done. Very good. You love to see it. Okay. Good, good, good. This is great. My old solution here was to use the output angles, but that would have a discontinuity at wormholes, where like if you imagine like Portal 2, where you shoot a portal here and a portal there, and you go in and you come out here, your camera angles change. The game has that, but without the visuals. So if I used the camera angles to train on, it would just suddenly like, and it'd go, oh, that's cheating! But it's not cheating. They just went through a wormhole. So what I'm doing instead is calculating their mouse sensitivity, how much it would turn the camera angles, and calculating the angle change contributed by the mouse. So that also doesn't include turn binds, which would mess things up. So it's scaled the same for everyone. So it should be way better. Previously, it was just using the raw mouse deltas, which like some people have higher DPI. So very bad, very, very bad. Okay. We're super good. I think this is actually done. This is angle angle dx and angle dy. Do it. Do it. Do it. Do it. Do it. There you go. VV nice. VV nice. That is so good. So good. Down. All right. Use angle delta instead of mouse delta. Looks like Iter Tools was already there. How is our format going? FTM. We have a little bit of formatting. Okay. Okay. So good, yes, everything good. Okay, it's all merged up. Yeah, baby. Runs the setting events first. Oh, that's so good. Okay. So now I need to figure out batching. My data set is way too big to fit into my GPU VRAM. Sadly. So what I need to do is batch it, which is a normal thing that neural networks do. It is batching. I have to actually do it. Training. So Right. It's like this. Help. Yeah, there's traits, and I have to implement the traits. Do I have the prelude? I do. Okay. Okay. No. Aye. Mm. Ooh ah. Ooh ah. Uh. Ah. Wow. Do it. N. What? I don't know. What? Don't be doing that. I don't really. You have that in the prelude? I freaking hate preludes. You know what? Screw you. No prelude. Get out of here. What? Oh, did it go down here? God damn it. Okay, buddy. Cross entropy loss. Cross loss. Haha. It rhymes. Okay, so then. Oh, do I not actually need that? Hold up. Okay. Sure. What even is that? Logits. Bool. I don't actually know what that means. But it's a classifier. It's from an example. I have to implement it. Gar. Rar. What incarnation is this? Tensor. Haha, we need tensor. Sure. Indeed, sir. Sure. Doom. Int. Ooh. Nine. I am confusing myself for sure. I'm gonna open the window. It's a little bit cooking. Okay. So I already have a training process. Here it is. Epochs, forward, backward, step. But it's like all, if you set it up right, all training processes are the same. So you can just like use the framework training process and skip writing this code. Oh, is that what it is? Is MSC, min squared error loss versus the whatever else I was writing, cross entropy loss? Why don't we research? Let's learn about it. What is cross entropy? Actually, why don't we do cross entropy loss versus MSC loss? Understanding the loss functions. Probability prediction P. When we train a machine learning model. Oh. That is a weak selection, text selection. Quantify the difference between predicted and true values. They are not interchangeable. Each is designed for specific tasks and data types. MSD is a workhorse for regression problems. The goal is to predict continuous values. Okay, and then cross entropy shines in classification tasks where the goal is to predict discrete class labels. Spam versus not spam. Well, I'm doing cheating versus not cheating. So, okay. Why is it preferred in classification? Okay. Right. This block demystifies. Wow. Is this written by AI? I mean, there's probably a lot of internet data about this, so even if it's AI, it's probably not too bad. Hat. Let's go. It's hat. Oh, loss function. Okay, yeah, no, we know what loss function is. Mean squared error. I know what that is. Cross entropy. Okay. Yeah. Okay, yeah, we already covered this. This is definitely AI. I'm kind of not digging this, but I'm just gonna like glean the nugget of information. Let's see. Right. Okay, maybe there is no nugget. Oh, look, a real actual formula. So what, this is like the mean value, and then this is the actual value. Mean squared error, yes, sir. Okay, where's the cross entropy? Yada yada. Ooh. Oh, no way. Absolute. How do you do derivative if absolute? That seems a little goofy. Treating all arrows equally, small or large, does not over penalize. Yeah. So you could even like, well, no, you couldn't go cubed or something. Not differentiable at 0. Unlucky, buddy. Converges slower. Because it doesn't prioritize the larger errors. Binary cross entropy. Only the second term matters. Heavily penalizes wrong confident predictions. Oh. Cool. What is categorical? Multi-class. Yeah, okay. Okay, so what we saw here is that one. Oh, cross entry. Okay, so it's not saying specifically categorical. We definitely want this. Oof. Class. So this is a. Is this a real thing? No. Okay, so let's look at the example again. That one. Classification batch. So I'm gonna need something similar. Batcher. Yeah. Okay, what was it? Categorical cross entropy and binary cross entropy. Okay, so log loss binary. Ooh, special. Holy, we have this binary sucker. Our problem is a binary classification. So binary cross entropy is like the one. We want it to heavily penalize confident predictions that are nearly wrong. So if it's like, that is 99% cheating, and it's not cheating, boo! No! Bad neural network! That makes sense! Oh, forward. Who, huh? Okay. Yes. Output, is that our... I don't think we need this. Oh, loss classification. Sure. Okay, so it's like, yeah, this is what we have. Oh my god, bro. Whatever. Just smash it in. Make it happen. It get the job done, and then we'll worry about some stuff later. I'm gonna paste. Self. Slice. Indeed, buddy guy. It's not images, it's users. Of course. Targets. Is that right? What is this output? B2. I think that cat would be nicer here, but I think stack is faster. I don't actually know. So like stack creates a new dimension, whereas cat has to like uh, concatenate variable sized lists. But if you just stack, then there is no dimension variation, and it's like a fast path. You just like all of them are the same dimension, stack them up, and then I can just like squish it back down. Is there a special case for like, I have a list of tensors, make it, haha, and they're all the same dimension? It's like cat, but all the same dimension. Maybe I'll find it later if it exists. Oof. Targets. Why? Forward. Clone. 2. Yeah. Is that real? No. Int. No. Int. Wait, int. Targets. High. Targets float. Targets clone float. XD. Like, bruh. Okay. Okay, so really, probably I can just like say int or something. Int. I'm int. Burn tensor int. Sure. Burn tensor. Is this tensor? Tensor int. Haha. Ooh. Okay. Right. So what is classification output? We have a classification batch. Where is that? Image dataset data. Show me the money. Dataset training.
Train step. Learner trained mal.
Who has burn prelude? Surely I didn't train or change that. Train that, eh? There it is. So, burn train step. Okay. Okay. Use burn train. I am guessing I need to enable that feature. Train. Rah. Okay. All right. Train step. It's still compiling. Okay. Inference step. Indeed. May I take your hat, sir? Okay, we don't get the red underlines yet. So we're looking at training, CNN. This is identical code here. Classification batch, classification output. These are not my types. They're somebody else's types. So we gotta import them. Who did this? Classification output. Auto diff backend. Backend. Did they change that? Oh. Struct. Tensor backend? Ayo. Oh. Is this real? Okay. Sure. Classification batch. Is that what is that? Hi. Data. So this is defined in the module. Training. New. Normalizer. What is an... I don't think I want that. No. So, probably I can get away with just not doing that, right? So it'll just be a struct that implements the friggity frick trait. Dot batch. That's not a trait, right? Oh no, it is a trait. Batcher. Okay. Okay. Training. Should we just smash it down here? I don't know. So I don't think. No. And then, batch. Indeed batch. Indeed batch. Do like this, right? So images, targets. No. So pub. I don't think we need pub. We can just have all this stuff in this one spot. And we go like, oh, users. And then this is vec.
It is my understanding.
Like that. And that is a batch. So it's a list of users replays. And then the idea is that I'll load a batch of users that fits into VRAM and then load another one and like cycle through them and then start a new epoch and cycle through them again. That's the idea of the batcher. Is that it doesn't fit in the VRAM. So you gotta make it fit. No way. All right. Okay. B, backend, B. I guess so. That's fair. Clone. Batcher. So I have a very simple batcher and like a normal batch. It's so normal. Everything is normal and simple. Okay, so now this is the old trait. Function. Okay. Batcher, batch. Image data set item. That is a me thing. Data set item. What? Is this loading image as UA? What? Oh, it's the function definition. Okay. Dot image into iter. Convert to UA. Okay. So it takes items, constructs tensors. Is this like cloning mega hard? I don't know. All right, this is a little bit confusing because it's quite a bit different from what I'm trying to do. I had an idea of how to do this yesterday, but okay. So in the end, it makes a batch. It's a batcher. It makes a batch. That's crazy. Users. Haha. Oh my goodness gravy. Item. Data set item. Why is that different? Okay, it's the batcher turns type I into type O. Input into output. It's like right. So the idea is that you don't have tensors. And you make tensors. And that like uploads it to the GPU automatically. If my understanding is correct. Okay. Sure. So that's the idea. So this is a list of thingies that can be tensorified. Why does it have to be a vec? I'm not a big fan of the like really strong ownership API. But at the same time, I know that it doesn't matter because all of the performance bottlenecks are elsewhere. But like, it's a systems language, and you can really do some crazy stuff with avoiding allocations if you try.
Rust. Oh, Rust. I love Rust. Let's go. It's Rust.
So what's in here? Right. So this is really the like loading step, kind of. Okay. So this is all inputs, and then right here, this is all tensors. So this is the part that we're gonna be batching. Normalizer. Ayo. Data. So this whole thing is replaced with like a training baiting thing because all of your traits are implemented. So I need this. Oh my god, bro. So I guess what's a good size? How do I know? Image dataset item. Where are you at? I'm an image dataset item. So this is like a list of users which I know fits on the GPU. RAM. I don't want to clone it, man. Give me lifetimes. Okay, we. It is a image dataset item raw mapper. Goodness gravy. Bretta. Really? Okay, this is like the inside. Wait. Dataset vision. Oh, this is like a pre-baked built thing. It's not part of this example. This is a thing dataset. Hmm. So where's the trait bound that says you need a batcher? Training. I am training. Mimi training. It is training. The data loader. Goodness gravy. Core data loader. It's a data. I wrote one of these before. Mine is probably slightly worse than this. Shuffle. Damn. Custom image data set. I am a custom image data set. D has arc. D implements the dataset trait. Data loader builder class batcher. Oh my god, bro. What is that? Why? Couldn't you like abstract this again and like train on multiple GPUs? Seed device train. Oh, wait a second. Training train. No, that's the function that gets called. Right? Yeah. So it's like, oh yeah, train, go. Okay. So there's no higher level abstraction. Supervised. Like, what would you do if not numeric? Numeric as opposed to symbolic training? Like, what? You're gonna like have a mathematically perfect AI? Paradigm. Jeez. It's kind of silly. Training.launch learner. Brother. As validation. Is that train valid? So I could like split my stuff. Okay, apparently you have to. I don't understand validation. So like I get that it's like part of your data set that you don't use for training to make sure that it's not overfitting. But does it influence the training at all, or is it just for monitoring? I don't know. This looks like a pain in the ass. Oh. Batch size to a fixed number. Box new fixed back strategy. Mine got. What else is there? Nothing. Okay. Trait bounds on top of trait bounds on top of trait bounds. Rar. I hate this stuff. Like, stupid. Um. 1. Multi-thread data loader. Hey, yo. ArcDin. Alright, I don't think I need to look in there. Or maybe I do. Strategy. I am the strategy. How does it get used? Our strategy. Force. It's not a good strategy for what I'm doing. I would need to like find the maximum number of replays that a user has and then like base it on that. I guess I could like sort by the number and have like the maximum possible in the data set size, but like that, yeah, then it's always smaller than that, and then like it doesn't fully fill up the batch size. I don't know. Probably I should just go for simple. Just make it simple, super simple. Probably what I should do here is like make batches pre-baked. Well, like, why do they want to? I don't know. I guess that's disk, right? Okay, so there's like disk and RAM. I thought I would just figure this out and then go. I'll be off to the races. Bruh. There's so many traits. Like, that is what I was hoping for, but it's definitely overloaded. Overloading me. I am overloaded. Check pointer. Yeah, that's cool. Man, can't I like just implement a couple traits and then we're good to go? Batch. Like I got it. Kind of. Classification batch. What is that? Int. Why does this expect 2 and this expects 1? What are you smoking? Training. Is it here? Okay, so what is this? Train step. Are we there? No. Training. Train step. There it is. Okay. You do this. B1 forward EXPR. Cross entropy loss. D. D. So it says this one and that one are the same dimension is what it says. Okay. And then this one has a specific size? Where are we at? I'm trying to implement a framework. The batching for training for AI. Why is it 2? Shouldn't it be 1? Cuz it's just a list. Let's see. Training outputs. Like literally it's just a list of 1 or 0 over all users. So why does it need to be multi-dimensional? So this one is like running through the network. And like you might have multiple is the idea. And that's a good way to do it. But this one is like, you're done. So can't I just say, we're done? Training samples. Or, okay. So this is like the size of the thing. And then this is like the number of the thing. So, okay, I see. So if I had more than one output, this would make sense. And I am going to change that. Did you learn AI for this? Yeah, I've been learning it for 2 weeks or so. It's AI. It's AI. Okay, so this is like the output is one object. So I think it makes sense to keep my thing with 2 dimensions. The number of samples and then the size of the output. And it is currently 1. And that's good. So it makes sense. So then this guy wants 1 though. What? What? But this is a batch. Do you have a job you do with these random sessions of coding? Nope. I am unemployed as hell. So I don't understand this. Why is this saying it wants 1 dimension? Wait. Wait. Simple classification output. Is this a binary classification output? Are we talking cats and dogs here? What's up with this? Classification. I'm classification. Learner classification. Are we talking like there's multi-label classification targets 2. Multi-label. Okay, so this is like implicitly a binary classification. The ground truth class class index. Class index. Index? Really? Oh, are you supposed to transform it into the index? So your network could have like a one hot vector that it outputs, but then you take that and transform it into the classification index. But we're like, what? Why would you do that? Oh, I guess that's like, I don't know. That seems. I don't know. I don't know. Okay, so I understand. This is just 0, 1. So this one, I can take it and reshape it and. Why is that int? Wait. Oh, this is the that one. Oh my god. Forward int. Oh. Why is that happening for me? What is this? Forward int. 2 int. Oh. 1 int. And then now it's like 99999. Output. Who are you? Not int. Classifier. I suppose I don't actually have a classifier. Like in this case, it is a classifier, but it's yeah, there's multiple ways to cheat, and you can do them at the same time. They're not mutually exclusive. So with a classifier, it's a cat or it's a dog. It's not 70% dog and 50% catness. No. So that's why it's like int like this. So the current way that it's set up is just like a classifier, but that's not what the true data should be. So basically my data set is wrong, which is nice. Boom, boom, boom. Okay, dot reshape, I guess. Ah, crap. Users.len. Okay, now is it trolling? Expected float, found float. Okay, now it's trolling me. What the hell? BEX, like what? 2. Why is it 2? Why is it 2 then 1? Make up your mind. Like, why is this one like good in the hood, and then this one is just like, it's just crying constantly. Forward. Okay, well it is binary cross entropy, so this one is. Oh my god, bruh. D, D, D. Forward. Expert. Okay, so this one is 2-1, and then this one is 1-1. Okay, so I guess what I'm not clear on is, do I want this guy? Learner classification. Two, one. 2-1-2-1. Can I just go to super learner classification? That's the only one. Adapted for multiple metrics. One hot. Insane. Multi-label. I'm dying, man. It's trolling me super hard. So this is DD. So it's okay. So necessarily this is trolling me. Necessarily these ones have the same size. D? Const D. And then necessarily these have a different size. That just seems. Wait. Well, then what's the difference between binary cross entropy loss and cross entropy loss? Because, like, you have cross entropy loss, then you have multi label cross entropy loss, which is like 3 or more labels. So, cross entropy loss is 2 labels, and binary cross entropy loss is 2 labels? Eh? Where? Where? Test. Boy. Like, the documentation is sorely lacking. A specific sample. 01. Number classes. Okay, so this is number classes. Cross entropy loss is not for 2 labels. It is for n labels. Okay. Boy, so then... Oh my god, bro. Is there freaking like tests I can look at here? Ugh. Tolerance. Smoothing. Smoothing. Schmigmoin. Who's... Oh. Test backend. Damn. I wonder if like they must have like multiple crates that define this, and then it builds all of them and runs all of them. It's cool. One test, many backends. Okay, so it all looks the same, and it's not actually using like the goober code that this is using that I'm trying to learn and copy. Okay, so this is not how it works. Okay, what is that? 1. What is that? 1. Like this is not what we have here. All right, well, let's go like this and like this and like this. Int. And then it hates me anyways. Int found float. Does this guy also wants int, right? Okay. Okay, whatever. Whatever. It's like there is exactly one output. Output. I'm just gonna have to figure it out when if I change it to like multi-classification. I'll just refigure everything out. Oh well, classification batch. Mine got train output. So goodbye. Everybody go away. Bye. Classification batch is over here. Oh my god. training. Oh, there it is. Train step. I guess this crap goes there as well. But it's like, I don't know. I don't know. Well, let's give it a gander. Okay, what intonation is train output? Data. Ooh. I am train output. Train. Model. Where does it say that? Where's the stuff? Where's the thing I was looking at and it does things? Is it here? Yes. Okay. Train output. Okay, that's a thing. Okay, we'll just smash it in. Okay, it likes it. It's like, sure. Okay. Sure. What the hell is that? There's 0% chance. Um. Oh. Like what? Why is it? Why is there no underlines?
Where's all the red underlines?
This is wrong actually. Inference step. Wait. What requires this? For validating. I guess. I wish everything was documented like that. I mean, I guess that's basically the level of documentation it has. Gah. Okay, Batcher. Is that freaking in this? Batcher? Nope. Somewhere else. Batcher. It's probably here. Data burn data. Data batcher. Batcher. Crikey. This is not real. So the batcher has to take a thing that has the data and make the tensors. A thing that has the data. I feel like this should all be in the training. So then all of my underlines are there. Boy. Okay. Oh my god, bro. Buddy. Okay, nice. B, right. 2B. Batcher B. B back in B. I do be doing. Okay, batch is B. What up? Missing generic. Oh. Okay. Okay, so now I need to make these pieces of crap. If it has to have ownership, what does that mean? Should I just like arc it? Like what? I guess I could have a vec of references. That would maybe work.
That would work. Ooh.
Um. What if I just try to do that? A reference to freaking batch. I don't know. Freaking cannot find type batch. What do you want? Type render? Yeah, no. Okay, so this is gonna make batches right here, and then I'm gonna be like, oh yeah, this batch, make it out of that. It's a batch. I got the batch. Batch. Batcher batch. Oh. Struct batch has got the data. So it's this shape but smaller.
Okay. Okay. Right.
Inputs. Oh, we want the targets as well. Oh. F60. Wait, what? F64. Why is that F64? Why is it F64? Why is that scrolling so fast? Bruh. Oh my god, bruh. Okay, so inputs, targets. I do believe we want little targets. Okay. That's a batch. That's a batch. It works. Let's go, baby. Okay, so you can actually just smoke a reference into that. And it's like, cool. So I don't need to, like, actually take ownership here. That's nice. Maybe. I don't know. Who knows? I have no idea. Okay, so users targets. Legitimately, you just do this. Actual, straight up, go. For real. Actual. Batch. Items? So it's like a batch of batches? Oh. Chunk. It's a batch. It's a chunk. Item. Okay, so now we have items. I do believe... I do... So I have to flatten it? This is strange. Item. They don't really exist in isolation. What? What? It's confusion. If I said bool, don't know. Getting closer. Slowly, slowly. Good. Oh my god, I'm gonna need to like... Actually, is it gonna split my data for me? No idea. There's gotta be a thing that can just do that. If I have batches, I could just cause I probably want like 80% of the data for training, 20% of the data for validation. I just think I want even less. Whatever. It's confusing to have a batch of batches. Like, what is item? Because an item is a individual image. Is that what's it? Images. Image dataset item image. Yes, it is an individual image. So that doesn't really exist in my data set. It's not so discrete. The smallest unit would be an individual user's times. Which I guess. I guess. I guess we could say that individual users times. So we could say user, and then there's no outer vec. This is still targets. Gabagoo. Oh. Oh. Nah. No. That's a... This is now... Like that. This is like... I am blacklisted, whitelisted. Batcher. Okay, so... Array user. I think things make a little bit more sense. So, items into ether user in no. User is reference to user dot inputs. Uh-oh. Multi-collect. God damn. Target. It's just reshaping for no reason. It's like pointless data transformations. As a programmer, your job is to transform data. So wouldn't it be best to like transform it ahead of time and then not transform the data as best you can? What's that? Oh, nice. Map collect. Can I collect 2 vecs at once? I forgot. Well, good luck to me. We're gonna try it. User dot target. Vec. Haha. Let's go. Inputs. targets. Okay, sure. Okay, so not real. What do you want? Mismatch B as device.
Okay. Right. Okay. Right.
Okay, the red underlines are fewer. Classification batch users. Okay. Okay. Right. So then targets items not length really. No man. Oh, it was into ittered. God damn. Um well, I mean we could just do targets.len, that would work. But then if we have different amounts, it doesn't work. So we need to do batch size or something. Num users, whatever, is equal to zoop. Try to naturally fit it together. Okay. Why are you doing this to me? Oh, it's a reference. Oh my god. Hi. That's right. User vac just kills me to like clone it all the time. They're not small. Oh well, that's the API. That's the way it be. All right, I cannot. I think it's like this, but then doesn't work. Um, yeah, no, I didn't think so. Yeah. Rawr. Okay, so we got a deref mine gut, and then wait, can I? Actually, if I, okay, clone, sure. Okay, what do you want? Private type in public interface. Okay, public interface. Like who? Okay. Okay, this is like step one. Oh my god, why is there? Implement some traits. Go. Good. Noise. Format. Unlucky. Okay, so something has happened, and yeah, I did something. Not sure what I did, but something. So now I want to like replace this code with like go do it yes code. So I need to like. Oh wait. Yeah. No, I understand. Okay, I understand. This is users 999, and then this is users dot push user mo. Collect wait, okay, so this push vec inputs just that's it. And then targets 9999. It's just that's it. Target is 1 point that's we got him. That's it. Wow. Wow. And then that's the same here. That's the same here. No. This is 0. 0. And then we got him. That's it. That's the way. And then, yes. And then now this is not real. And we do not care. This is not real. We do not care. This whole thing. No. We run something that looks like this. Users. Vac user. I have no idea how this is going to work. Batch size. 1,000 probably would be okay. Well, actually, no. There's only. It probably need to be like 100, because there's 1,000 blacklisted users. Those have. Oh wait, there's 530 whitelisted users. Really? Oh, I see. That makes sense actually. Okay. So we probably have to watch out for that. Yeah, we probably want. Well, 100 is like. Maybe it might be like nearly the whole data set. I have no idea. Oh, do we pick a number? If it doesn't work, make the number lower. Done. Okay. Rate this code. Training.launch. I am training. I am launching. What if I don't want to validate? What if I don't care? Oh, is that supervised training? And I can just like frickin' not? And I can just be like, yeah, no, I just want like unsupervised training. Okay. RL. Oh my god. Evaluator. Boom, 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 boom. Okay. Not real, not real. None of it is real. It is fake. Oh, don't do that. What is perplexity? What the hell? F. Unsupervised. Me, hello, who did this? Okay, we read. I'm gonna read. La 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 la. Provide users a well-crafted, flexible training layer so present to write such components from the ground. Much interactions will be the supervised training struct. Yada yada. Configure training loop. Support for registering method. Yeah. Assumptions. Inappropriate for learning requirements. Assume your model will learn from a training data set and be validated against another data set. Most common paradigm. Supervised and unsupervised learning. Okay, so that's not what it means. More complex requirements. Custom training loop might be what you need. Oh my god. Data loader builder. Custom. Oh, you still got to write your epochs? No. Validation loop. Well, that's straight up what I was doing. Run. What's this? Learner. dot dot dot. All right, well, it should not be very hard to split my data set. So I'll just like go with the flow, split it up, eat it up. God damn it. Okay. Rar. Okay, we'll just do it like this. Mimi test data model. Okay. Now training launch. Okay, let's just. What is that? Seed B? B. Uh, okay, here we go. Data loaders B. We can just say, nah. Device clone. Really? You don't. Oh, for real. Who are you? Data loader builder. Hi. Do it. Great. 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 Who is that? So this is like own struct. Oh hey, that's like what it is, isn't it? Epochs subcommand. Okay, so I just don't have that. Wow, wow, wow. Seed num workers. Epochs. Training. Ah. Ah. Doesn't implement debug. Okay. Mm-hmm. I don't know, man. Okay, so let's just say batch size 50. And we'll call that the best choice ever. Batch size. This is a little bit skooky. Okay. Workers sounds like a good idea. I think I'm picking up what you're laying down. Probably like 4. Oh, look at that, 4. Woo-hoo! Okay. I see. They put the defaults on that. Oh, one of my favorites. It's an 8-minute song. Oh. We're no longer using this. That. Do. Looking good. Let's go. What the hell is a seed? 42. Okay. Looking good. I just doesn't matter. Well, U64. Okay. When's the Strafe Client coming out? Tough question. Directory is crazy. Um, so for a real answer, it would be maybe like 3 years after I figure out how to do the physics. Basically it's never going to be done until I figure out how to do the physics. There's 5 crazy physics bugs that I don't know how to fix that are mind-numbingly complicated. And I just have to grind away at those until they're done, and then the project can progress. If you can't play the game, there is no game. The physics is the game. So it's just not ready yet. Yeah, I'm just kind of learning new things and trying stuff. Yeah, it requires a lot of perseverance to make a game engine, of course. Date strings. I don't think I need this. Solve all these critical errors. So I'm working on AI right now. I'm learning about how to make AI. All right, Artifactor is. What is going on over here? Artifactor. Okay. Best surfing platform. It's gonna take such a long time to do by myself. There's no guarantees I'll even do it. It's mainly the physics. Like, we've created all of the other infrastructure for the Roblox game. It's just the same thing again. Like, we already did it. Browser's cool. Yeah, it's really just the physics blocking everything. And if I can figure it out, then it's unblocked. This is not real. Dataset, not real. What the hell is a dataset? This looks annoying. Oh. Wait, what? Data loader builder. Dataset DI. I? Buh.
Data loader builder. Data loader builder.
Image folder. Okay, so this is like... Okay, so I have to implement the dataset trait. I guess we're just walking trait bounds. Um... implement some code, whatever. It just doesn't matter. Save. Oh, have you seen the intense barrage of memes in the Surf Discord server? Surf? Do you mean the bhop and Surf server? Or is it a server that I'm not in? Intense barrage of memes. It might be close here. Learning result. Data set. Probably. Oh. Users. Okay. So this guy goes down here. Oh, mutt. No, we don't need mutt. Okay. Well, I mean, I guess we can still name it. Okay. Train valid. Hi. Data set loader builder. Bruh, 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 bruh. Okay, so um data set train data set valid is equal to um so we need to construct split data set. Data set split freaking I don't know. What I don't know. I don't know. Users, whatever. Users. Something. I don't know. Just write something. So then frigging like this and like that. I think that's good. Okay, let's call function that doesn't exist. The classic. The classic, the classic. Okay, so now we don't have any leftovers. Comma, call function that doesn't exist. Nice. Nice. I have to implement this data set thing. Wait, is that real? Oh, no. Oh. Oops. Okay. Oops. Oops. R surf. Okay, so it's a server that I'm not in, so I definitely haven't seen it. Roblox bhop slash surf. Okay. Split data set into train valid. Split train. Sure. Function. Sure. Okay. So now we have friggin' struct. Friggin' I implement the trait data set. So I can rename this stupid thing. users. Sure. Users data set, I don't know. And then impl data set for users data set. And then freaking function split it. Users is something, do something, something. Indeed, vec user, my good fellow, and returns a users dataset situation. Yep, go for it. Friggin' item is user. For real. Index. What? Why? Okay. Sure, bud. Okay. Sure. Sure. Okay, that's not very hard. Self dot freak frack. Users freaking frack. Feck user with a lowercase s. Self dot users dot get index. Self dot users dot len. Option user. That is. Oh, we want reference to user? Uh-oh. For select time. Alright, we can just go like this, right? And then do A, and then we're good. A? Okay. Okay. Empty hallways at 3 a.m., 9 p.m. Dun, 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 dun. Okay, that implements that frick. So apparently we want this. Does not live long enough. Lie. That's a lie. It's does not need to be mutable. Okay. Init device num params. Yeah, buddy. Sure thing, man. Why? Dropped while still borrowed. Dataset data loader train. How is that possible? Declared here. Reference. What? Oh, static. Oh, the ownership requirements are killing me. Oh, getting close, getting close. Okay, so it wants static, so I can't do this. So I gotta freaking goddamn clone the entire stupid idiot stuff. Which, like, whatever. Just clone it. Go for it. Clone it. Clone the whole thing. Whatever. Whatever, whatever, whatever. Clone it, clone it, clone it. Freak. Do I need to, like, map? Ugh. Clone. Why is it option? Okay, clone. Is it what? No, it's clone. Duh. That's right. There you go, bud. All right. User doesn't do clone. Find user. Hi, I'm user. Debug. Clone. There you go. Okay, and then the little trainerino. We just go like that, and all good in the hood. Inputs. We can now go into iter. Ha 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 ha. Because we have ownership. Ha 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 ha. And then we don't need this or that. Into iter, into iter. Okay, calm. Oh my goodness gravy. Okay, we're almost there. Split the damn data set. Split it. Okay. Random numbers. I need random numbers. Random numbers. I guess I should. Yeah, that does make sense actually. To like sort the users by like user ID, except you don't know that. God damn it. Whatever. We can like work on determinism later if it's necessary. Friggin' RNG. I guess actually no. We kind of want to pull these out separately. Okay. Fine. Into iter. Whatever. It just doesn't matter. Just doesn't matter. Okay. Into iter collect. Let blacklisted equals dataset to blacklisted into iter collect. Map user collect. How did he do? Okay. There you go, bud. And then same deal. Whitelisted equals to ding ding dong dong dot into iter freak collect. Okay. Go next. Okay. Um. It's my function. Let's just do it. Okay, we have 3 separate lists. Dum dum dum. Way, and then just take the first and then put them in the data sets. Okay. Um. How do I like it just doesn't matter. Okay. Um uh okay. Pick 'em. Go. Um Split into iter collect. Mm. Do, 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 do. Blacklisted train, comma, blacklisted valid equals to blacklisted dot split at dot len frac semicolon that's extra allocations. Should I just like into iter and then take? So let's try iter. Let freaking iter. I am iter. Why? Gotta hit this. Okay, so it mutt equals ding dot into iter dong, and then freaking we have 2 data sets. I think I can do it like this. Users data set. Users is freaking mutable reference take jeez. Oh, you know, I could have a numerator and denominator. That'd be good. Um, that's nice. Okay, take let's do blacklisted valid times frac num frac den. We're trilling. Okay, so this is something, I don't know, man. Okay, this is, yeah, valid is equal to, hello, it's me. Blacks is valid, collect. Oh, chain, 99999, chain. And then same deal, chain, except we can go like this. And then chain, not chain. Why did it do that? Stop doing that. What the hell? Okay. And then let train equals users data set. Goddamn. Users. Goddamn. It. Chain. Dot chain. Chain. Dot collect. We don't got it. Semicolon. Oh my god, bruh. Okay, train valid. Crikey dikey. Okay, so then that goes there, that goes there. Okay. Good gravy. Okay, woo! Dataset split. Split dataset. Ugh. Okay, the data. Wow, it's the data. Okay, let's look at the training. It's the training. I am the training elapsed. Model save file. Frickety frack. Bam, bong, boom. Put it in, go make it done. The training model. Okay. Hi. Save. GG. Oh my god. So, there it is. Maybe it'll do something now. Where is device? Net init device. Training launch model. M. Can you do like multi-device training? Let's see. Burn a multi-device training, because I do have 2 GPUs, and like I figured out this like framework thing. So they have stuff. I mean, I guess it's just so expected, but like, where's an example? Multi GPUs. Yes. Whoa. Naive aggregation. All reduce. Is this training? Grad sinker. Good gravy. This looks like not training. Batcher. Data loader builder. We're not training. Wait, backward. We are training. What? Handles devices map. Handles. Join unwrap. Data sets. All right. That's nice. Whatever. Okay. A good luck to me, I guess. Train time. Train. Train. Yeah. Just like a wee little number of epochs. Tiny baby epochs. Oh my god. Is this like... Why is there so much crap going on here? 500... What? Oh, okay. Okay, that's interesting. Okay. Okay, so it's going to look totally different. That was a lot of crap to build. I'm gonna put the coffee away. It'll take a second. I betcha it's gonna fail. Oh, it's doing something. What do you suppose it's doing? I suppose it's loading up the models. We can open another terminal and view CPU usage. Oh, I probably want to do swap file. Otherwise, I'll die. Okay, we can see the RAM going up. Here is the memory usage. We could even filter by AI. And here's the actual memory usage. It is climbing. It should be about 5 gigabytes of data. Oh. $200%. Oh, the VRAM is going up. Oh my god, is this gonna actually work? I'm doing 16 epochs. It's only using 3 gigs of VRAM so far. I'm not sure how it'll end up. Yeah, I said 50 users per batch. And 4 workers. Which sounds good to me. Oh! What? Oh! What? Did it just do a full epoch? That is slow. Items 300. Wait, it's done like 1 epoch. Epoch 89%. This is slow. It's really cool though. Like, look at this. Look at this. I'm gonna open up yet another terminal, and we can see the GPU usage. Is that under my camera? Yeah. I'll do this. That'll work. So, here's my GPU that I'm streaming with. As you can see the encoder running. And I'm training on my second GPU, which is the slower one. I have no idea. I have no idea. Whoa! Whoa! 3 hours. Wow. Wow. 3 hours for 16 epochs is terrible. Horrible, horrible, horrible. That is so slow. It's cool. Let's go. Okay, it's done a 1 hour. Oh, jeez. Okay, yeah, it's doing 50 at a time. Using 8 gigs of VRAM. So I my guesses were pretty good. Um. Oh, right. That's with 4. Okay, so it's probably using about 2 gigs per worker. I don't know if I want smaller batches, more workers, or more workers and larger batches. Probably for this, I want smaller batches, more workers, because the batches are wildly variable size from 1 to like 100 replays. Oh! No way. Well, that run is dead. Did we even do a single epoch? I don't think we did a single epoch. Is that the same error I already ran into? 5037. I already reported a bunch of errors. That sucks. CubeCL. Issues. It doesn't work. No one said a thing. Panic when using this and that. Let's see. Core. Scalar. Yep. It just... Wait. Is that the preventable one? Okay. Filter map? Okay. So the problem here is that the timelines have too few frames. So there's like 16 frames overall in the timeline, which is like a fraction of a second, which is too short. Oh, I'm doing way crazier stuff as well. Wait. Okay. Okay, so it needs to be, let's say it needs to be at least 3. So it's like 3 times 2 to the power 7 times 7, something like that. We'll just go with that as 2,600 times 7. It's probably more like this. 896 times 7. No, it'd be like plus. I don't know. I can just. Okay. So I have to filter out short replays. But that can cause the user to also need to get filtered out if the list of inputs is empty. Okay. I guess I can make this into a function because it is a function. Oh, it's already using a closure. Okay. Frick. I don't know. It just make it, okay? Make it. Users. It's probably actually can be a closure like this. Indeed. That's it. Users dot into enter. There you go, bud. So it's literally just AA that function, and we're good to go. And then, does it hate me? Yes. Okay. Wait. Why would I need an explicit type there? Oh. Well, that's pain. Okay, whatever. Never mind. There's different types. Can't be doing like that. I could actually use a macro, but macros are insane. So, okay, that's the timeline. Okay. Yeah. Okay. So it's filter map. And then this is sum. And this is bracketed. Let inputs equals to this. And please let me do things. Sum. Okay. Okay, we're in there. So then now filter map. If timelines dot input events dot length is less than min frames, then return none. Semicolon. Yeah, min frames. U size. We'll go with 2 seconds long or something like that. Just probably good enough. We'll see. Okay. So then if now. If the inputs is equal to 0, Yeah, this is probably gonna kill me, but if inputs len it is empty, return none. Semicolon. And dead. Okay. Vec something, please. Okay. My God. Okay, so then we just paste this again and again and again. Wait, is this the same every time? Oh my God. Okay, easy clap. Okay, we got him. Okay, so filter out replays that are too short, and that was the problem. Filter out replays that are too short. Oh. So the data set was so huge that it took 1 billion years. 3 hours for 16 epochs is just quite overwhelmingly slow. Okay, let me try adjusting the numbers here. Yeah, I'm thinking like batch size of 1. And num workers of 50 type stuff. Yeah, but that means I can make the graph less complicated, I do believe. Yeah. Wait, where is this? There it is. Forward slash users. Yeah. So I think I can actually just do one user at a time. Wait, what? Isn't this literally just like this? Okay. Yeah, so then the batch is a single user. I think that makes sense. Yeah. Why don't I just hold off on that? I'll just do it the stupid way first, and then I'll make it smarter after. Whatever. It's stuff. Indeed. Training. Set the numbers. Let's do 200 workers and 1 batch size. Because then it's 1 user at a time. And it doesn't overload. Yeah, I have no idea. No freaking clue. Let's give it a go. It might be faster. Try small batch. Many workers. It might just blow up. I have no idea. There might be a lot of like overhead. Okay, it's generating the data. There's about 500. There's about 5 gigabytes. Which is wrong. Yeah. Why do I want to say 500? I wanted to say like 500 decibytes or something, decimegabytes, but I couldn't think of that unit. Okay, so then the data is loaded, and then it splits into batches. Oh, wait. It's not like smashing out the CPU? I thought that if I had 200 workers, it would start blasting CPU or something. Oh! Illegal address. An illegal address. Great. Great. Simple sync MMA. Great. That's not nice. This is what I expected to happen the first time, and I was shocked when it didn't happen. Well, do I make a new issue? I don't have a lot of information about this. Check the experiment logs here. Well, let's look at that. Actually, it's already open. Well, isn't that nice? Mm. Freak. kubectl runtime pre2 panic. Let's double check that it's not a duplicate. Actually, I know for a fact that's not a duplicate. Okay. Juice. There was a problem. Uh, crash during training. I don't know like what else to say about that. With Batcher. And now I can include the experiment log. Experiment. Experiment. Uh, uh, Let's go, baby. Uh. Okay, what can I do? I expect that the number of workers here is like messing with stuff. The list of users, list of length 1, batch size 1. I don't know. Well, let's do fewer. I don't know. What did I change? Filter out, replace they're too short. Right. Okay, so I changed the number of workers to be huge, and that was tough. So this isn't gonna work. Okay, it's at. So it's at 54, and I'm changing it to like basically 450. I should try. Well, 550 would also work. Because it would. Trust me, bro. It was using like 8 gigs of VRAM. Small batch, many workers. Okay, good luck to this training run. Load up the data. I guess I should make like a parallelized data loading thing just to be a bit more speedy, less waiting. All right. Let the batching begin. We should see the memory climb. Is that 1%? Oh dear. Once again, an illegal memory address. That is a different error. Oh. This is becoming like a different problem than what it was originally. Originally, I could just like run it and it was good. All right, I guess I'll start. noting. All right, is it? Burn kubectl fusion. So this is on this other repo. Doesn't belong here. Yeah. I'm dying. I don't know, man. This is a lot of broken stuff. All right, so it says fusion, so let's disable fusion and see how that goes. Don't do that. How can I write this down? I don't know. Yeah. Okay, it looks like. All right, it's saved. Okay, disable buggy fusion. Let's run it again. Yeah, I don't know. It's 3 hours. Jeez. Yeah, I think I'm just gonna have to change the architecture. I, I hope it can run at all. It's just not working. I should just make the source code not closed, cause like what are people gonna do? Train a model that like does moderation for my game? And then I can post reproductions for all of the crazy bugs I'm getting here. Is it too much to ask for it to not crash? Yes, apparently it is. Wow. That's an absolutely phenomenal amount of bugs encountered. I'm not looking forward to making reproduction conditions for all of these. I'm having a hard time believing that the framework is not going to crash if I put more effort into this. And that's wearing me down. Let me try downgrading. I wonder if I get the ancient error. 20.1. That's like ridiculous. How many bugs I just hit. I don't believe. I don't believe it's even gonna work. I think it's gonna fail like very fast. I do want to like simplify the graph because it is per user. I could make the batches exactly be the users, but like it seems like having lots of these workers triggers this. So this is comment 1D. Uh, um, uh, 50 batch size equals 50 workers 4. To 200. Some more information. What's going on here? Okay. I have no idea what's going on here. I don't know. I'll just let it figure itself out. Yeah, I guess it's compiling the optimized kernels. At least it hasn't crashed yet. He said expecting it to crash momentarily. What is iteration? Wait a second. You can't get. Oh, look at that. The GPU's going. Oh, no, that's the wrong GPU. Oh. Wait, what? Wait, what? Is this just training on the wrong GPU? GPU ID 1. What? Like, it does say the device in the model. That's the only thing that says the model, which is interesting. I do find that interesting. Oh. $20. Why is the VRAM there? This is confusing. It's doing something. Oh, you know what? I guess this. I have no idea. This is weird. It says GPU device is 0. Whoa. This is GPU device 1, 64 gigabyte swap. Well, that's how much RAM I have as well. Except one RAM stick is dead. Okay, so it's definitely using the wrong GPU. What the hell? Okay, so that might actually be why it's so slow. Is it has the model loaded on GPU 1 and it's training on GPU 0. But it was what? What is going on? What are you clicking? I'm making an AI that says whether or not you're cheating in my game. You're cheating. You're cheating. But it very much looks like it's running on the wrong GPU. Like, I can kind of deal with that. Is there like settings? Can I just say like learner.device? Checkpoint. Learning checkpointer. No mention of device, which is fair. I mean, it's doing something. 21 hours. Oh my God, we reached 1%. Something wrong. Something is not right. Would that even work? Batch size. Well, I guess I could like force it to be one item. That would work. Batch. Because then I can use a simpler graph. So like this crap is like wacky graph. This graph, simple graph. Oh no, I still need the subgraph. I don't know. I don't know. I just don't know. I think that this is a waste of time, and I should stop it. Stop it. And quit. He's not even responding. Dude, like, Control C, man. Kill. Goodbye. Good day, sir. Okay, I'm thinking I switched to GPU 0 because it is just kind of not working properly. But like, I can roll with GPU 0. That's okay. I would prefer to use GPU 1 because I'm using GPU 0 for streaming. But if it can't handle that, that's okay. So all I've really done here is change the batch sizes, and it's gotten slower. So let's switch back to big batch, small worker. I'm thinking 100 batch and 2 worker. Big batch faster. All right, good luck, bud. Go
Eat your heart out.
so the problem with big batches, actually, wait a second. User, no, I can't. No, I can't choose. It does its own thing for batching. So like this like batch strategy thing, which doesn't exist in this code, is saying it's a fixed batch. So supposedly I can do my own batch strategy. I don't know what that entails. So batch strategy, add an item to the batch, and batch size. Push. Swap. Why not clear? Oh, because it's going to return it. Okay. I see. I don't know. Items. So what is okay. Okay, none. Okay, so it's saying it doesn't want a batch. Okay, I think I understand actually. So it keeps calling batch add. Or something like that. And it broke. Classic. Can't allocate a buffer of size. Oh. Well, we're just out of memory. That's why I wanted to use GPU 1. Yeah. Okay. But it doesn't want to use GPU 1. So the pre-release is insanely buggy. The batcher is insanely slow. If I make the batch size too big, some of the items are huge and some of them are small, and it'll just randomly encounter a bunch of huge items and run out of VRAM. What do I do? I guess I just sit there and take it. I just sit there and it just is mega slow. I wonder if I can do 100 with one worker. I have no idea, man. No idea. So 100, I have no idea. Let me try the old strat, because that was actually running 50 and 4. That was using 8 gigs of VRAM. Right, that's why I was typing 40 here. I don't really need to keep compiling this, but I mean, it'd be nice if it worked. Crash again. It crashed again. Oh, why is it running on the wrong GPU? Like, where do you specify this stupid device? 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 Set device. Oh, is that the problem? So what? It was just using default, and that was the problem. Probably. All right, just relax. Let's try again. Oh god, it's gonna kill me. Okay, you good? No. Die. Drop. Okay, let's try setting the device here. Clone. Okay, set device. Right. Okay, set device. Let's try that on GPU 1. See if it can run in a faster time than 20 hours for one epoch. I do not believe. God, this would be, I have no idea how I would do this in Python. I'm upsetty that it crashes so much. Loading data. This is 4 gigs of data, 3.9. We need 5 gigs of data. And now we wait for this to do whatever it's doing. Hopefully it starts. Yeah, no, it's just loading the wrong GPU. No, that's not going to work. Yeah, there we go. Why is it using the wrong device? This said device number 1, And it's using device number 0. So if I use the old version, it runs on the wrong device. If I use the new version, it crashes. That didn't work. Well, let's try the stupid batch stuff again. So 100 was too big to run on GPU 0. $40 and 4. Okay. Good luck running on GPU 0, because I can't seem to control it. Oh, I guess while this is doing whatever it's going to do, I can write the faster data loading. I didn't want to write async code. I guess it doesn't have to be async. It's just easiest to do that way with like a future stream load. Actually, I don't feel like doing it. It can just be slow. I have yet to do some serious training here. Okay, we can see the VRAM going up now. Hopefully it doesn't overflow. This is so touchy. I don't have enough VRAM. I don't have enough compute. It doesn't make the compute graph. It doesn't like, what is it, saturate the compute properly. It's just shite. I need to come up with a plan, because this ain't working. Well, maybe it's working. We'll see. I'm only running one epoch. I mean, if it can run one epoch, it can run 1,000, right? As long as I can resume, I should be able to. I should be good to like run a few per day, right? Run a few per day. I need like 1,000 epochs. I need like 10,000 epochs. What is that? So it said 2 hours for 16 epochs. So that's like. So if I need 10,000 epochs divided by 8 times 1 hour, that's like a fifth of a year. Like 2 or 3 months. And then it's like, okay. I already have a model that's okay. I need to train it in like an hour so that I can train it and then test it and then iterate. This isn't the final design. I'm not ready to invest 3 months training this. Like, I would totally let it sit and train on my server or something, which has like a piece of crap GPU, but it is a GPU. If I thought the result was worth it. I'm disappointed. I can say that the ergonomics are quite nice. The framework that I'm using. Really the only problem is that it crashes no matter what, basically. It needs to cook another 2 years. No, that's not the only problem. Like I guess what I'm doing is weird, but it's precise to like train a bunch of differently sized tensors and then take the maximum output of those in like a huge computation graph. Very weird. It handles it very poorly. It's very slow. But it's an accurate model of my problem. I just don't know Python. And I don't want to use Python. Oh. Well, I learned a lot. I actually was able to implement the learning batcher thing. Oh. Too much data. I guess I'll just reduce the size of the data set until it fits and go back to the old way. Because it was decent. It sucks. I want big data. I have the data. I've got 600 gigabytes of data. It's collective years of gameplay. Oh god, that's looking full. Yep. You know, it'd be nice if it used the GPU that's completely free instead of defaulting to the wrong GPU. That'd be nice. I'm tired of this. I think I'm going to end the stream for today. I am out of mental resilience, banging my head against the wall. I did accomplish what I set out to do, which was to implement the framework batcher. It just doesn't work. The framework does not work. Okay. I'll try something else tomorrow. I don't want big data. I am in a better place today than I was yesterday. I learned something new. Okay. I'll figure something out. Goodbye. Maybe I'll make my own batcher thing.